So the last paragraph that we're going to read is paragraph 6, and if you would please just go ahead and mark it paragraph 6, put a marking somewhere, and we're looking at two questions that we've been thinking about all the way through this reading so far. Can we determine the mass of an atom, and can we determine the density of an atom? Or maybe more accurately, does the density of an atom affect the density of a substance? Or in this case, an element, Okay, so let's read the paragraph. Atoms of the same pure element have the same number of protons. So atoms of different elements have different number of protons. So, for example, the element oxygen is going to have 8 protons because the atomic number is 8. But it's also going to have, if it's pure, it's also going to have 8 neutrons. However, an atom with 9 protons in its nucleus is going to make up fluorine. There's 9. So an atom with an atomic number of 9 is going to have 9 protons, and if it's pure, it'll have 9 neutrons. It'll have an atomic mass of 18, but it will be a different atom entirely from oxygen, simply because it has a different particle count, and specifically because the proton count is different. So fluorine has 9 protons, oxygen has 8. You can use the old-fashioned Bohr model, and this is what you've seen a sketch of earlier, with the energy rings and the nucleus in the middle and the electrons in the electron cloud around. And we can show how many protons, neutrons, and electrons are in each atom of an element. And what we're about to do is to actually sketch some atoms and engage in some activities where we're creating atoms. We're sketching them, or we're creating them. We're using PhET lab to create them, and we're going to be actually creating our own first 3 periods of a periodic table. So we'll be having a little card with each atom on it, and basically you're gonna show how many protons it has, how many neutrons it has. You're going to show the particle count, the atomic number, and this is going to be a totally cool activity. You're going to enjoy it. We'll do it in several different ways, and I do want to show you this one little. I have some notes here I want you to take a look at, and you can write these down. Copy them down. I'll probably give you a glue in at some point with them, but it would be a good idea for you to pause this video and get some of these down. But the atomic number, and let me clear this screen so you can actually read this. All right, here we go. Important facts about atoms and the periodic table. The atomic number only shows the number of protons. Don't become confused and think that the atomic number ever tells you how many neutrons there are or how many electrons there are. The atomic number specifically is a number. It's a quantitative measure that tells you how many protons are in a given atom. Okay, so that having been said, the number of protons defines, or it shows, or it tells, it defines the element. And I can tell that by counting the number of protons, going and looking on the periodic table to find that atomic number. And whatever the element is, it has that atomic number. That's what that proton is going to be. All right, the atoms of a pure element have the same number of protons. So atoms of a pure element all the atoms, say of pure gold, are going to have the same number of protons in them. So, and this is important in understanding that whatever the number of protons are in a given atom, you go look at the atomic number in the periodic table, and many of you will memorize the first three periods, but you go and you look at the table, and however many protons there are, that's the element. Okay, so in a pure element, there are the same number of neutrons and electrons as there are protons. So the particle count and the electron count will all be the same if we're talking about a pure element. Okay, so atoms of a pure element, atoms that are pure of an element, going to have the same number of protons, neutrons, and electrons. Now the atomic number still only tells us how many protons there are. Isotopes have the same number of protons as a pure atom of a given element, but the number of neutrons is going to be different. So the particle count will be different, and the atomic mass, which is the particle count, will be different. And then finally, the periodic table shows the chemical symbols of each element. And this is something that you are going to need to pay attention to. The, carbon is an uppercase C. Lithium is an uppercase L with a lowercase I. Always the first letter of a symbol is capitalized, and if there are more than one letter, then the other letters are lowercase. And you are going to be expected to use proper capitalization when you're showing or writing the elements. And so these first three paragraphs that we've looked at, and I just would say grab yourself a blue marker and let's just get the main ideas in this paragraph underlined. So can we determine the mass of an atom? Yes. How do we know the mass of an atom? It is the particle count. And can we determine the density of an atom? We're going to just say the jury's out on that still. But we can say that the density of the substance, the density of an element, will be determined by the atomic mass. Which is the particle count. Okay, so let's get these underlined. Atoms of the same pure element have the same number of protons. And atoms of different elements have a different number of protons. Okay? So these are, you need to put a star by these. If you don't understand this, listen to some of these videos again, go over it. If you still don't understand it, say, Mr. Woods, can you talk to me about this? Can we do something with, with our hands that will help us to understand this? And you guys, we are going to do a number of activities, hands-on activities. They're going to help you get a hold of this. So if you've read these six paragraphs and looked at these 6 videos, this was paragraph 6. If you've looked at all of these, then you're well ready for the activities that we're going to do in class that are hands-on, and we'll come out the other side of these in the next couple of days, the next couple of class periods, and you'll understand much better about the density of atoms, atomic mass, the density of substances that atoms make up, and all of that. So, all right, so it'll be a few days before we put up the videos, before I ask you to read the rest of the paragraphs, and I put up the videos for the other paragraphs. But we'll be looking at the last several paragraphs in this reading, probably first thing next week. All right, enjoy.